Thank you very much, ma'am. Uh, Good evening, one and all. Uh, I welcome all the participants to the last session of 6 days online faculty development program. I hope our team of experts are giving insights to enrich your knowledge in the domain of quantum computing and its security. Now, I will take privilege to invite our speaker one more time, Dr. Kishore Kumar Gajula is distinguished academician, researcher, and technologist with 18 years of combined experience in academia, research, and IT industry. He holds a PhD in computer science and engineering, and he currently registered postdoctoral research, presently serving as head of research and development at News and Infotech Hyderabad. He specializes in cloud computing, blockchain, artificial intelligence, and machine learning. He has authored more than 45 research papers, 4 books, and 3 patents, and has conducted and organized several international and national conferences, FDPs, and workshops. He is recipient of prestigious awards, including the Young Researcher Award 2023. Dr. Kishore actively contributed as a PhD guide, keynote speaker, and editorial board member of multiple international journals. I would like to invite Dr. Kishore Kumar sir. Sir, welcome you, sir. Over to you, Kishore sir.
Yeah, thank you, sir. Thanks for inviting me. Good evening, all of you. I think today is the last session for the entire FDP program in our college. So today's session is a completely just overview to the complete safe mechanism in machine learning and one more real-time examples. Nothing but a real-time capstone approach is how we can working with a real-time quantum applications. So we will look into that completely real-time applications. I think if anyone is opening with a Google from the laptop, you can open the Google Colab. I think most of the people know about the Google Colab for using of running of a Python programming. Today's session we are working with a quantum, IBM quantum techniques. So we can work with an IBM quantum techniques. I will show the example how it will be work with an quantum random techniques and how it will be generated random numbers to one or one to manys. So how it will be encrypt and how it will be decrypt the key. And if there is any key mismatch will be there, how the algorithm will be alert to the user. I will show it in the real-time example. So before that, one more small topic will be there for us. Just it's in a 5 to 10 minutes of time. That's it enough. So over a I'll share a screen. This is a small topic. Quantum safe machine learning securing it in the post-quantum era. So here, how the quantum computing is securing the machine learning models. So that is the main and small concept in the last final session. So here, what is the quantum computing fundamentals? Almost all fundamentals all completed. This is the fundamentals of one more time. We need to recap how it will be work. So in the fundamentals of quantum mechanism cryptography, first is a superposition method. It is an 1-0 or 0-1 and 0-1 or 0-1. That is the superpositioning. And entanglement, that is a pavement of a qubit methods. And then neo-cleaning theorem is nothing but quantum states cannot be copied of any other detection techniques. And quantum uncertainty, measuring of one property affecting with another property sets. Right. So this is the QKD. I think so. Most of the sessions in the quantum cryptography. So quantum techniques, all of the sessions that QKD, I think all 13 sessions QKD will be common, right? So I think much more known about this. So physical layout security and reverse dropping detection and future proof of keys. So quantum computing, that is the classic computing and then quantum computing. So classic is an a 0 or 1 and the quantum is an a 0 and 1 method. So operations are limited to the in classic computing and quantum computing. So in this session, we are going to work with a quantum computing. That's computing with work with an IBM quantum computing. Right? So we can run the IBM quantum computing program in Google Colab. Right. So it's a hands-on session. The entire session, this session is only the hands-on session. Right. So quantum building blocks, that is a gates and circuits. So quantum gates are the main gates we are using in the quantum, that is an and or not. Right. So quantum circuits are initialization of stages. At the stage initialization will be in a 0 and applying to the all the gates at in a sequential order. So quantums can be generated in a qubit method. The qubits are all states included in the sequential order set. So it will be work within a proper output. Right? So in that the complete quantum algorithms, the base and the strongest algorithms are these two algorithms, Grover's algorithm and then Shor's algorithm. So actually, I'm trying to work with the Grover's algorithm or Shor's algorithm, but it's not possible to work with a direct with using a Google Colab. That's the reason we are not working with this Grover's algorithm and Shor's algorithm. So in that Grover's algorithm and Shor's algorithm can work within a particularly deployment of an IBM cloud or else any Pi clouds, external quantum clouds based only, it will be work. It doesn't support to the Google platform. So it's not showing in a proper output. Just it will be showing up in an algorithm structure and it will be allocated within a Google methods. Right. So and then simulation will be there. We can access within a Google simulations or else Google simulators. We can generate a cloud-based map plotting information. So there is a base quantum thread to machine learning. So what are the main threats to the machine learning? How we can overcome with the quantum computing, right? So public key encryption token is the main threat in the machine learning subject. So how we can overcome means that is a public key encryption. It's a general topic. So with using of an RS algorithm should be used for the connect qubit method accelerating to a particular attacking models. Right. So this is a simple concept of an quantum computing, that is an harvest now and decrypt later. We can encode and it will be accessible information at later. Right. So this is the future development of an implementation of a quantum threading methods. So now we are into the stage of 2025 to 27. It's an accessing with an 2084 bit RS algorithm. That is nothing but 2 MB RS algorithm bit encryptions, right? So it's an working with an PQC is nothing but post quantum computing techniques for critical systems. So it will be working with an completely in our research area. After 2030, it will be going to execute in the real-time scenario of a quantum, right? So with using of a post-quantum, how we can store and how we can access. That is in a same lattice method, hash method, code-based, and multivariates, right? So here we can check with a real-time application. Yes, this is one of the best example, right? So now we can work with a Google Colab. So from who are working with a laptops or desktop or mobile phones also, just open the Google Colab once. So others, I think participants please respond for this session. For hands-on session, easy to access. So for any kind of algorithm, first we can work with a step-based. So I will explain the process of steps. So you can directly work with a directly in information set, right? So let's open your screen and I will type it in the same in the notepad also. Right. Yes, all of you open the Google Colab in your laptop or mobile phone. Also, mobile phone also it will be work. Just open the Google Colab and log in with your mail ID into the Google Colab. So first step in any kind of online Google Colab or online platforms, we need to install the libraries, right? So I am saying that that is a we are working with an a quantum. Our main motto of the project main motto is quantum random number generation. This is our main motto. Right. So what are the prerequisites for this means we need to install the libraries. So first we can install few libraries and next we can work with an libraries. So what are the install libraries will be there. So we can work with an libraries. So how we can install the libraries in the uh, Google Colab. So simply first we can go with an pip install So that is a QIS kit. It's nothing but this is an a QIS means. So here quantum information science kit. It's an open source library for an IBM quantum computing, right? So it's an open source library for quantum computing framework for IBM working structure. So whenever we want to access of an IBM properties, IBM quantum computing properties into the Google Colab properties, access with an running with an Google Colab, this library is an mandatory to install. So it's an access with an Google Colab, right? So that is a pip install US kit, right? So, and then we need to install one more library that is within this QI kit hyphen AR 5 crypto do. It's nothing but this is the library for accessing and conforming within a working with that is the pip install QI kit script AR. AR means that is a completely air. That is a simulation method. That is access for an this library is access for an AR means air. And PyCrypto. It is a Python cryptographical library. That is a PyCrypto. That is a PyCrypto. That is a Python cryptographic library. So we need to install here. That is a pip install QS kit. This is the access with an IBM library for allocation to the Google Colab. Next, QS kit AER. This is the sub library from the QS kit. It will be installation of an AIR library. That is a simulation library. So it will